All right, today we're putting on our detective hats. We're going to dive into how understanding the internet's deep structure is basically giving us a brand new superpower in the world of cybersecurity. So where do we start? Well, with our first big clue, of course.
So here's a question that keeps a lot of people up at night. In an age where everything is automated, where we have all these high-tech security systems, why do major cyber attacks still keep happening? It feels like a paradox, right? We've got more tools than ever, but the bad guys are still getting through. What's the missing piece of the puzzle? That's exactly what we're going to figure out today.
Okay, so let's get into cybersecurity's big automation challenge. We're talking about the promise, and yeah, the peril, of tools like SIEM and SOAR. These are supposed to be our digital bodyguards.
Right, so in any modern security operations center, what we call a SOC, you've got these two absolute workhorses, SIEM and SOAR. Think of SIEM as the lookout. It's constantly scanning, just mountains of data, looking for anything suspicious. Then you've got SOAR, which is the muscle. It takes the alerts from SIEM and actually does something about them, automatically. There are 24/7 automated frontline.
But, and this is a big but, there's a huge problem. These systems are lightning fast, no doubt about it. But they've got this massive blind spot, a real intelligence gap. They're great at spotting individual clues, but they totally miss the big picture.
So here's what happens. A security alert goes off. And what does this system give you? Usually it's just a single lonely clue, an IP address. You can think of it like a detective finding a single footprint at a crime scene. I mean, it's a start, it's something, but on its own, it's just a string of numbers. It doesn't tell you much.
And that one little clue, it just opens up a flood of questions. Like, who owns this IP? Where in the world is it? And the really big one, who is it talking to? What's it connected to? And traditionally finding those answers has been a super slow, manual job for some poor security analyst who has to go digging for that info.
And this is really the key takeaway here. Without that extra context, our fancy automated systems are basically flying blind. Is that suspicious IP address just some random person on a coffee shop's Wi-Fi? Or is it a massive server run by a company like Google? Or, and this is the scary part, is it a critical piece of an attacker's network? The system has no idea. It can't tell the difference.
So how do we solve this? How do we give our systems some glasses so they can actually see? Well, we give them a map. And I'm not talking about just any map. We're talking about a map of the internet's entire DNA, its core structure. This is where something called a network intelligence graph comes in.
And this leads us to a really cool piece of tech called WhisperDB. What is it? It's a special kind of database, a graph database, built from the ground up just for security. Its whole job is to build a living, breathing, searchable map of the entire internet's infrastructure. It's all about connecting the dots that have been disconnected for way too long.
So what's actually in this map? Well, it's a whole bunch of things layered on top of each other. You've got the official records of who owns which blocks of IP addresses. You have the actual routes that networks use to talk to the rest of the world. You even have the peering paths, basically the handshake agreements between the big networks. And then you layer on top of that things like DNS records and even data on how websites link to each other. It creates this incredibly rich, multi-layered picture of how the internet really works.
Okay, so having this incredible map is awesome, but that's only half the battle. The real magic, the game changer, is when you plug all of that raw intelligence directly into your automated defenses. That's when you turn all this data into real immediate action.
And this table really breaks it all down. It's the so what of all of this. On the left, you see those gaps we've been talking about, right? The automation problems. In the middle, you see the specific piece of intelligence from the map that fills that gap. And on the right, that's the cool part, the brand new capability you get. So for example, that unknown IP origin problem, bam, you use RIR and ASN data to instantly know the owner and the country. That painful manual research, that's gone. Now you can automatically map out an attacker's entire setup in seconds. And best of all, instead of just blocking one little IP, you can use the network data to block their entire network. It's a massive upgrade.
Okay, I know this looks a bit like code, and well, it is, but stick with me. This is the actual language you use to ask the graph questions. It's called Cypher, and it's built specifically for this kind of thing. This is how a person, or even better, an automated system, can instantly ask that super smart internet map for information. And in plain English, all that code is really asking is a pretty simple question. Hey, show me every single network that's directly connected to Google. That's it. I mean, just think about that for a second. Imagine having the power to ask a question like that about any network on the internet and getting an answer back in a split second. That's a serious game changer.
So, what does this all boil down to? What's the bottom line? Well, it's a huge shift in how we deal with threats. We're moving away from being reactive and slow to being proactive, super intelligent, and operating at the speed of the machines themselves.
So check out this new workflow. A threat alert comes in with a suspicious IP. But now, instead of a security analyst frantically opening, 10 different websites to figure out what's going on, the automation itself just instantly asks the network graph for context. And it doesn't just see the one IP address, it sees the attacker's whole network, its neighbors, any domains they own, all of it. And with that full picture, it can deploy a block that isn't just a tiny little pinprick, it's a decisive, wide-reaching strike that can take out the attacker's entire operation. And just to give you a sense of the scale we're dealing with here, get this. A single one of the data sources that feeds into this graph maps 2.7 billion hyperlinks between different websites. That is a mind-boggling number. It uncovers this hidden web of connections that attackers have been using for years, a web that defenders just couldn't see before.
And all of this brings us to one last, really important question. For so long, attackers have had the upper hand because they understand how the internet is all connected, how all the pieces fit together. They use its complexity against us. So what happens when our defenses finally understand the internet just as well as our adversaries do? What becomes possible then? Well, it just might be the thing that levels the playing field for good.